That's a lot for the marking stuff.
Oh. Bella. All right, guys, so I have a question about number 4. Look at me remembering stuff. So if you haven't tried this yet, this is a very, very, very standard nuts and bolts problem. That's a problem you can, that's one kind of problem that you can guarantee is going to be in the test. It's going to be exactly like that. I'm just going to change the function. So, what do I need to do first to do number 4? Yes, because if I'm looking for a local maximum, that's where I have to define the derivative, get the critical numbers, make the sign diagram. Absolute extreme of max or min. You should go, oh, good. It's a lot less detailed. All I have to do is take the derivative so I can find the critical numbers. And once I have the critical numbers, what do? Circle them in right now. Put them in where? Yes, then you check the endpoints and any critical points that are in there. And you see who wins. You guys understand? Absolute extrema is just who got highest, who got lowest. Who can enter the contest? Critical numbers that are in the interval and the endpoints of the interval. If my interval does this and stops here, isn't that an absolute max here? Would it be a local max? Shit, no. It looks like it's going to keep going up. So absolute maxes and mins can happen at the endpoints or at the critical numbers, right? See if I can this is interesting. I don't think I can make a concave down. There I am. Am I doing? Yeah, sorry. It's like chewing gum and walking or something. So if I wanted to take this guy's derivative, what would be involved? Product rule, yeah. So let's see. How do I take this guy's derivative? So if I want to be nice to myself, I can say x prime e to the negative x squared plus x e to the negative x squared prime. If I write the rule for myself, I can then completely focus on the one piece that needs the derivative at a time. I still think you guys want to do it quickly, and then you have all this stuff in your head, and not all of it gets to the paper, and then things go crazy. What's the derivative of x? That's insane. So this will be e to the negative x squared. And then what's the derivative of e to the negative x squared? E to the negative x squared? Negative 2x, yes. Now what am I going to want to do with this thing? That's the derivative. I'm trying to find the... We took the derivative, and now I want to find the critical numbers. Where did critical numbers come from? The critical number stored. No. Huh? Where it's 0 or undefined. Is that ever undefined? That looks like everything's in the exponent there. I wrote that weird. Is that ever undefined? Oops. No, because e to the power can never be 0. So there's no, so 1 over e to the power can never be 1 over 0. So there's nothing that makes it undefined. How do I get it equal to 0? Well, I set it equal to 0. Bless you. All right, now this specific problem doesn't mean shit. This specific problem does not mean shit. Because you know I'm not going to give you this problem. I'm going to give you a problem just like this one. So what's important is the steps, and why did I do the steps? It's always what's important when we're doing a problem together. Why is he doing the thing he's doing right now? The more you know that, the more you can do it yourself. Yes? So when I have an absolute extremer problem, the endpoints have to be given to me. They're going to be candidates. So I'm going to plug those in for sure. I just have to see if anybody else made it to the contest. I got to see the critical numbers. What do I do now to solve this? Somebody's very softly saying factor maybe back there. What can come out of these two things? So you're left with, what's this divided by itself? 1 minus 2x squared. Can this ever be 0? Because there's an asymptote at 0, right? So that doesn't give me any answers. Can this ever be 0? Yes. If x squared equals 1/2, is that cool? Add the 2x squared, divide by 2, and then I love how you guys look at me. Okay. Add the 2x squared, divide by 2, and you get to where I got. And then what's the last step there? Take the square. Sorry. I've been with you guys for over 5 weeks, and I'm still getting used to the fact that so many of you are like telling me to steal first or something, or steal first is hard. Still second. You're making these signals and you're mouthing at me, and I'm like, I'm not good at reading lips. So x equals plus or minus square root of 1/2. You will be armed with a calculator. What do I need to check now? Do both of those get plugged in? No, they don't. Because what do I have to check? How do you get into the contest? You're either an endpoint or your critical number, that is between those two. What is the square root of 1/2?
Very small.
That's so true, sort of, not really. Depends on what your scale is. It could be tremendously huge if your scale is the width of a human hair. Huh?
0.7.
Yes, 0.7 roughly. Yes? So is positive 0.7 in our interval? Is negative 0.7?
Yes.
Ah, good. So the negative 0.7 critical number got into the contest because they had to be between this age, and that one was within the ages. The other one's too old. He's an old man. Yes. Is that? Now you just plug shit in. Is that okay? What am I going to plug in again?
-1.
And where am I going to plug it in? So I'm going to plug in -1, 0.5, and of course,
-0.7.
no, negative square root of 1/2. 0.7 was good enough to determine which was which, but I need to know exactly what the alpha is. Is that okay? And then you just step back and see what's the biggest, what's the smallest, and you circle those. Max, min, next. Could you have a tie? Hell yeah, of course you could have a tie. So there could be 2 maxes. There could be an infinite number of absolute maxes. Does that sound weird? I know. But sine x. If you don't think there's an infinite number, you must not think there is an absolute max. But isn't there an absolute max? What's the absolute max output? 1. How many times does it get there? Infinite number. There you go. Infinite number of absolute maxes. Okay. You're like, math is weird. This, I know. Thank you for the question. So I have set aside like all of today to gear towards whatever you guys, and if you're like, don't need to hear what I'm saying, like I said, work on corrections, right? Get those out of the way now because they're due tomorrow. Yeah.
On test 3, can you just go over how to do that?
Just 3B. Did you have a question about this or it's
No,
different?
that's another question.
Okay. Hold on to that. Test. 3B.
Yeah, that's the.
Number 3B?
Yeah, that's FCOF 1, but it's like switch
Wait, test 3.
1B.
1B, I'm sorry, okay.
Yeah.
Oh, yeah.
That's when we're flipping.
Which one did you have? There were 3 different.
I had the one where it was
So if I give you,
It was ln of 5x on the bottom.
Sure.
Position.
sure, I'm not gonna do anybody's specific thing for them. Did you have a specific question about?
Yeah, it was doing the chain rule part of it,
Sure.
because I know that we have to do the inverse of it, so like make it negative to flip it, and then we
Sure.
just input the ln of 5x, and then we have to do the chain rule with that.
Sure.
And I think I screwed.
What's the derivative of ln 5x?
It's 1 over 5.
Times?
Yeah, times 5.
5. So it's 1 over x. So you just have to, at the end, you just gotta put a times 1 over x.
Okay.
Yep. So chain rule is kind of nice. You take your inside and then you just make a link at the end. That's why we call it chain rule. It's a link of things. So chain rule just adds another link at the end. At the end, I'm going to put a 1 over x. That's the derivative of the inside.
Okay.
Is that cool?
Mhm.
Okay. Yes. Oh, sorry. Calista, and then yeah.
Oh, number 10.
On the practice final.
Yes.
Oh yeah, okay. So, I didn't make a huge deal out of this, which is one reason why I put this on the practice final. This problem, it's by itself, correct? So that should kind of hint that there's something weird. What do you think, if I'm trying to find the area under a function, between the function and the x-axis, one way that can go to shit is if there's somewhere that it goes to infinity, yes? Okay. On the interval we're interested in on number 10, does it ever go to infinity? Is it ever undefined? Yeah, so at -1, my interior function is undefined. So in terms of this class, that's not doable. Next semester, one of the sections you deal with what's called improper intervals, right? Intervals that are doing things that are socially unacceptable. And then you gotta figure out how to work around it. So the answer to a problem like that could actually be finite. But all we have to worry about is it's undefined at a place that it wants to be evaluated between, so I can't do it. Just like I just said. Not doable. Not integrable. At least as far as we're concerned. Well, yeah, well. Did you have a follow-up on this, or?
Are you gonna have any questions like how it's not doable as Tyler?
I could.
Okay.
Yeah. It'll be sort of obvious because I always would put it by itself. If you see an interval by itself, you should slow down and go, all right. Yeah, go ahead.
That's too deep.
Oh yeah. So this is like number 1 on the quiz, on the test, sorry. I even put Koch in there, and I don't give a shit, because, let me see. Here, I remember I was gonna do this. Can you guys, just, here, guys. What is the square root of 149.387 squared? Yeah, would you square this? Of course you wouldn't square the dumb thing, because the problem wants me to square it and then unsquare it. So I'm just gonna be like, screw you, problem. Take that pearl over there and then take the pearl over there. I'm done. All right. Yes? Maybe? So, if I give you an integral and I ask you to take its derivative, you don't integrate. Because the derivative is the opposite of integration. Because what's another thing for integration? What does an integral do? It finds the area, but it also is the what of the function? The antiderivative. So what's the derivative of an antiderivative? Those should cancel out, yes? And just to really make this clear, what's the square root of x squared? No, absolute value of x. So I like this example because don't the square and the square root cancel? But do they just directly cancel, or do you have to be careful about how they cancel? You have to be careful, yes? So an integral that I take a derivative of, they cancel, but we have those rules about how it gets plugged in and chain rule. You have to be careful how they cancel. So if I have this, the answer to the derivative of this must have this form in it. That cannot change because I am undoing the integral of it. So it stays the same. So how does the derivative of an integral work? When I say integral, I sound a little drunk. It's not me, it's the judicial system. If you say judicial, you sound drunk. Judicial. So how does this work? When I take the derivative of an integral, how does that work? What's the first level thing that happens? Is everything in the right place?
Yes.
Totally. Constant on the bottom, x shit on the top. So what's the x shit do when I start to take the derivative?
Shove it in.
Shove it in. So the first level of this, the immediate derivative rule, is to shove it in. That is like any other derivative rule. What's the derivative of x to the fifth? 5x to the fourth. How do you know that? Because we talked about the rule for how to take the derivative of x to anything. There is a rule for how to take the derivative of the integral of shit. There's a rule. Exactly the same idea. There's a rule for it.
Change.
Shove it in. On top of that is the inside piece more than just x.
Yeah.
So then chain rule comes into play. Chain rule doesn't care how weird the derivative is we're doing. It just says, hey, where there's normally an x, is it more than just x? Yeah, okay. Do me. So what's the derivative of x squared? 2x. This is the derivative of any integral. Take what's up here, put it in. This is what happens anytime the inside is more than just x. Does that make sense? Anytime we're doing a derivative and the inside is more than just x, chain rule comes into play. Exactly. But it only shows up, let me say it better. Chain rule will only show up when the inside is more than just x. Is that okay? Who asked that question? Is that okay? I forget who asked. Okay, so did I skip anybody? All right, you and then you. Good, sir.
Can we do 9C?
Did you have a question about this, or? Oh, I'm sorry, go ahead.
It's greater than x, do you like,
Do it again.
when you said what is greater than x, is it like a number in front of x or x?
No, if it's more than just x, not greater than. So like that's x squared, more than just x. Sine x, more than just x. 3x, more than just x. Anything inside that's not just x needs a chain rule. And like Dominic just reminded me, like I told you guys, we always do chain rule. It's just if it's x, it's times 1. So it doesn't show up. Sorry.
9C.
Oh yeah, look at that guy. Yummy. Now, listen. I so understand that calculus in 6 weeks. You guys have lived through it, so you know it's not the easiest thing in the world. We haven't looked at these kind of problems a lot. We haven't lived with them much. But can you start to see how I look at that and I say, oh, you saw. Two things. Do you know what function I took the derivative of to get that just by looking at it?
No.
If not, the only other thing it could be is either, well, two things. Either I can simplify something. Can you simplify anything? Let me help you. No. Or it's u-sub. Yes. So if I said integral of secant squared x dx, what's the integral of secant squared x dx? Tangent x plus c, right? Because that's a straight up, I know what function that would have come from. I know what function I would have taken the derivative of to get that, yes? That is the base level integral problem, is just a straight up undoing of a derivative. This still wants me to undo a derivative, but the function that I'm looking at, I have no freaking clue. Actually, I do. I have no clue where that shit came from. I need some help. You guys, so what I want you to realize is, what is it about the problem that tells me I have to use u sub? If I can't just tell from looking at it, and there's nothing I can do to simplify, you know I'm gonna give you a problem, sort of like either something that if you factor it, like the one on the test, if you just factor the damn thing, something, and then it's an easy interval, yes? Or you know for sure I'm gonna give you some kind of a trig identity. Oh, Jeff, we like you even better now. Oh, no, I'm gonna give you bad review out here. So you know I'm gonna do it. Because I have to. Because that's part of this class is keeping trig alive. We've got to keep the trig alive, especially if you're going to take out 2. Alright, so if you look at a problem and you're like, okay, I can't straight up do the integral, and there's no simplification, it must be u sub. 90-something% of the time, the thing I let u equal is what's stuck. Does that make sense when I say stuck? Is there any part of this that's stuck in something else?
Yeah, the x to the fourth.
X to the 4th businesses, yes. So, this could be wrong. Maybe you missed something, but I'm going to write u equals all that shit inside the radical and then take a derivative. Try it. If you haven't tried this problem, let u equal, not the square root, let u equal this stuff, and then take its derivative. Yes? X to the 4th through 123. So what's du, everybody?
4x cubed minus 8 dx.
dx, there we go. Get you so programmed saying plus c, I didn't integrate yet. Why does that tell me I'm in the right track?
This is kind of the same form.
Because what's the whole idea of u sub? I want to let u equal something whose derivative is in there also. Is that directly in there? No. But is that in there absent a constant?
Yeah.
Yeah. And we have complete control over constants. I can take them out, put them in, I can make them whatever the shit I want to. So how do I make 4x cubed minus 18x show up?
You need to multiply your 2x cubed minus 9x by 2.
So if I multiply this by 2,
You need to add a 1/2.
I better multiply by 1/2 at the same time. So really, like I did that one time, I'm multiplying the whole integral by 2 over 2. I'm bringing the top 2 in, and I'm leaving the bottom 2 out. I like to look at it as I'm taking the half away, but I'm adding 2, I'm multiplying by 2. So overall, I just did nothing. No bowler comes from me. I just stroll out nicely, and then people start throwing spears at me. Things happen. 70% of people don't get my references. Is that so? How do I continue from here? Where can you see your du? Is my du in here somewhere? Do I see this?
Not yet.
I do.
Yeah.
Do I see this? I do. So these together are
You.
du. So the 1/2. We won't put the 1 and 2 there because it's going to change. This business is du. And then what's this?
You.
Well, the inside's u, so it's u to the 1/2. So we let u equal this. There that is. Which meant du was all this shit, so we made that show up. And now look at that integral. That's bodacious. What this integral is saying is you had something to the 1/2 whose derivative was in there also. U, du. U, du. So it uncovered, or actually sort of like, yeah, it unburied the form of it. So now I can do the form and then I can throw the details back in. All that matters is, bless you, I have something to the 1/2 times its derivative. That's what this says. That's what that says. So if I solve this and throw u back in, I'm done. So what is the integral of u to the 1/2? U to the 3/2, so then multiply by,
You divide by first.
so multiply by the reciprocal. So you multiply by 2/3. Alright. Is that okay? Who asked that question? Is that okay? Yes? Okay. Yes? Yeah, why wasn't it there in the first place? Because it just wasn't there. What did we need for du? 4 and 18. I had 2 and 9. So if I double them, I can get du. But what's the only legal way to put a 2 here is if I multiply by half at the same time. So if I could magically double your age, and then somebody else magically cut your age in half, you stay the same. Right? Okay. So as long as anything you do does not change the problem mathematically, you could do it. I could have multiplied everything in there by 17 billion. As long as I divided by 1 over 17 billion. That shit wouldn't have done anything for me, so I didn't. Yeah. Yes. Sure. So what is the integral of u to the 1/2? What's the power become? 3/2, right? You add 1, so 1 plus 2 is 3/2. Whatever that is, I divide by it, which is multiply by the reciprocal, yes? So you know you're going to get fractional powers. Everybody freaks out about fractions, which is not great, but I understand. But they're not that big of a deal. They aren't. If I want to divide a fraction, I multiply by its reciprocal. Screw the divide fraction. I don't want a big ass freaking fracception looking monster thing. No, just put the reciprocal on front. And then what happens here?
The 2's cancel.
Yeah, so I get 1/3 u to the 3/2 plus c, and what was u?
U was the x to the
X to the 4th minus 9x squared plus 123, blah, blah, blah. If you can't read that, then I got the answer key. I'll give it to you later. Yes.
Can you set up question 5? It's the related rates one.
Oh yeah. So this is a more kind of standard geometrical related rates problem. So draw the picture and then label 2 things. The physical dimensions of the whole thing, and then what's the whole problem about? What's the whole point of the problem? What are you talking about in this problem? I need you to say it because I can't say it. Huh?
Are we trying to have a bonus?
No. Nope. Number 5, right?
Okay.
So what's it asking for? What's number 5 asking for? Yes! So what is this problem about? The frickin' water! Yes? The water. Screw it, the water. So if you draw the cone, if you can't draw a cone, draw an upside down triangle. Because then you're basically taking a cross section. It's all you really need. Right? Also draw in the middle some line that represents where the water is at that point. Yes? Because what do you need for a related rates problem? One of the first things you want to do is identify what your variables are. And if you give yourself a visual, if it makes sense, then you can label stuff and realize, oh, this is changing over time, this isn't. So over time, is the cup changing shape? No. We're not going to bring deformity and shear forces and shit to this because we're not in engineering, so I'm not going to do that. So the shape of the thing doesn't change, yes? You with me? So therefore, 10 and 3 are set. They're true. But what's changing is where the water is. So do Do you see how, therefore, wherever you put the water, you need variables for that position because it's changing over time. It doesn't have the same number. Yes? So, if I draw a upside down, well here. Here's a cone. How about you? Make a little like ellipse, and then you draw things down. Or you can just draw a triangle, yes? The radius of the whole cone is 3, and the height of the whole cone is 10. Draw in your water. I need the same dimensions for the little cone that my water has made, yes? Isn't there a little cone of water? Water is just like cats. It takes on the shape of whatever container it's in. Does anyone have a cat? Do you know what I mean? So there's a theory that cats are liquid. What's this? Huh? No, definitely not. Hell no. When do I bring this in? Later. Yes? That's the snapshot. What I've drawn is an arbitrary position of the water. So what is this? Huh? X if you want to. What's even better? Because what is it actually physically showing? Yeah. So you don't have to use certain letters ever. But dear God, why wouldn't you? Be nice to yourself. Call this shit H. Because it's the height. We get to choose. You could call it freaking box head and draw a little box with little eyeballs. But why? So I'm going to call this H. What else do I need to know about the water cone? The radius. And what are you going to call it? That's insane. Jacob can do whatever he wants to. I don't care. So again, you don't have to call the radius R. You don't have to call the height H. But why the hell wouldn't you? Dear God. Now, I didn't put it on this paper because I've given it to you before, but if I give you this problem in the test, just like on the, no, it was a different thing I gave. I will give you the formula, yes? But does anyone know the volume of a cone formula? 1/3? Yes. 1/3 pi r squared h. This entire problem is about the water. But what about the water? That's the only thing this problem cares about in terms of the water. The height. It's the only thing it cares about. The problem only asks me about and tells me about the height. So what variable do I want to get rid of? I want to get rid of r. I can't just erase the shit. I gotta replace it with something to do about h. Does everybody see why this problem only cares about h? Because what do they ask me? And what symbols would we use for that? How fast the water level is rising. What symbols would we use for that? GHDT is how quickly the height is changing, yes. And what's the snapshot they tell me? 5 centimeters. And that would be the value of H. Does everybody see then how this problem doesn't give the first shit about R? So we're like, let's kill it. Yes. Again, only an math lesson, not a real life lesson. Who cares about real? No, do it. So, what do I have to focus on now? Now I've identified for myself. I don't want R. What do I try to set up? This is a very classic similar triangles. I need to figure out, in general, I need to figure out a relationship between my two variables, because one of them I don't want. So if I knew R was 3H, I could just put a 3H in place of R. I don't know that. What can I set up from my similar triangles? Okay, 3/10 equals R over H. And you're going to solve for what? This feels backwards, but you're going to solve for R so you can replace R. And then you'll only have one variable. The volume is dependent on H. Yeah, just multiply that H. 3H over 10. So throw that shit in place of R. Is that okay? I love you guys. With with the state of mathematics, I just think that you guys don't get to live with what's called mathematical modeling much, which is the fundamentals of word problems. Just figuring out what your variables are, how are they related to each other, those kind of things. So this assumes, calculus basically assumes you've done some of that. I get a feeling that some of us maybe have not done much of any of that, which is just the way it is. So, yeah. So if I solve for r, I multiply by h. And then this, I just replace r with it because I just told myself that r equals that. And then what do I do with that new volume formula I just made once I plugged it in? Take the derivative because it told me. What did it tell me? It's asking me dh dt. What did it tell me? dv dt. Yes? So if I take the derivative, I'm going to dv dt related to dh dt. So I can plug in all the shit I know. So we'll relate volume to height. And if I take derivatives, that's going to relate change in volume to change in height. So if I know one of them, I can solve for the other. So go ahead, if some of you guys look at me quizzically, replace r with 3h over 10. And then figure out what the new volume formula is. Quizzical. Test. So just say quizzical. Some of you guys try to like skip forward something. No, just do one thing at a time. Replace r with what we know it is. Then what do I do with this? Because what's good old, please excuse my dumbass son say? Exponents first. So some of you guys would kill the 3. You can't do that shit. You can't multiply before you exponent. Right? You can see that. So what do you get when you square this? 9h squared over 100. Now the 3 can reduce with the 9, right? Don't you have a volume in terms of height? So then you can take the derivative of both sides. Plug in what you know, solve for dh dt, and go, next Jeff. Got it. By the way, what was that problem? Oh yeah, the other, word problem stuff. There was a problem on the test that basically everybody had this shape of a region, yes? And real quick, guys. If I ask you to sketch something, some of you guys, I don't know if you think you're just supposed to know what every function looks like. Holy shit. If I ask you to draw a rough sketch of something, what's a really good first thing to figure out? Intercepts. X-intercepts. Y-intercepts. Yes? You guys kind of with me? And most of the time, you can figure those out and then just get something in the middle, and then you get a general idea of what it looks like. Yes? Or you do like a just graph it and then copy down and copy it weird. And I'm like, what the hell's going on? Now, in this problem specifically, it wanted a rectangle inscribed in the first quadrant, inscribed in that function, yes? So a lot of guys, a decent number of guys got this step right and then just sort of stopped. So here you go. There we go. So how tall is this rectangle? It's y. And how wide is it? So what's its area? That's what they asked me. Did I tell you anything?
You told us the function.
I told you what y is, correct? So then can't you immediately just replace y with what it is? Y is equal to 5 minus x over whatever I think. There were 3 different versions. One of them was 6 minus x over x was 2. Right? Do you guys understand which problem I'm talking about? I'm telling you how to do it right now. So area is xy. Some of you guys put area as 2xy. Somebody put 4xy. I'm not sure where this came from. This is just x and y. There's a problem in the book where you had to go this way and that way, and that's why it was 2 x's. But here I just cared about the first quadrant, right? Once you replace y with the 6 minus x over x plus 2, whatever the hell, what do you do then? Take the derivative. So some of you guys, you saw the word area, and you started integrating. No. What is the actual key word in that problem?
Maximum.
Maximum. How do you find the maximum blank? You get a function for blank, take its derivative, get the critical numbers, yes? So the operative word in that problem was maximum. And the maximum occurs at a critical number. Could be during 0 or undefined. Could be this. You guys understand? So a few of you guys were trying to integrate stuff because you keyed on the word area. But area was just the thing, the physical thing we're trying to maximize. So it's an optimization problem. I'm not coming down on you, trying to help you see how to set the problem up. So a lot of you guys set it up beautifully, and you just weren't sure where to go from there. Huh? Oh, yeah. So, remind me, where do maxes and mins happen? When the derivative is? No, when the derivative is 0 or undefined. So you find the critical numbers. Once you have the function you want to maximize or minimize, you take its derivative, you get the critical numbers, and then you see which one's biggest or smallest, whatever you need. Okay. Alright. That was a question I asked myself. So I'll do that every now and again, and then I'll answer for everybody. Does anyone have any specific questions or general? Yes.
Could we please do practice final 8C with the limit?
Aha. So what form is that limit in?
Definite.
Yeah, be more specific.
0 times negative infinity.
0 times negative infinity, so it's indeterminate.
Indeterminate.
Yeah, which is worse than undefined or something, yeah. What do you wish you could use then?
L'Hopital's.
L'Hopital's. You with me? When you see an indeterminate limit, and it's not like an easy ratio that you can factor or something, you should think, oh man, I wish I could use L'Hopital's. Why can't I use L'Hopital's on this the way it's written? It's not a ratio. L'Hopital, French guy as he was, line up the ratios for whatever reason. I don't know where it's going to work. So, how can I make this? I want to force this thing to be a ratio, because then I can use L'Hopital's. So I don't know if this is where some of you guys does everybody understand that 3 is equal to 1 divided by 1/3? Is 3 a ratio the way it's written? No. Can't I make it 1 divided by 1/3 now is in a ratio? Yes. Which of these two functions is worse? This one or this one? Which one's worse in terms of doing calculus to it? ln. So leave him alone. Don't make him worse. Don't make him even worse by putting 1 over him, yes? So I'm going to take this to the bottom. I can't just move that down, because then I've made the problem different. 3 does not equal 1 divided by 3. 3 equals 1 divided by 1/3. Yes? So what's another way to write x minus 8? Do it. 3 is 1 divided by 1 over 3. X minus 8 is 7 is 1 divided by 1 over 7. 28 is 1 divided by 1 over 28. X minus 8 is 1 divided by... No. 1 divided by 1 over x minus 8. multiplying by x minus 8 cannot be equal to dividing by x minus 8. If I wrote this, if I wrote x minus 8 ln x minus 8 equals ln of x minus 8 divided by x minus 8, can you very quickly tell me why I am so wrong? What is the quickest way to just tell me, you are wrong, Jeff? What do you do again? You teach math? If I write this shit, and I just did, look at me. I should quit. My dean fired me. Why? How could you very quickly tell me this is bullshit? What is the operation here? I'm multiplying this by this. That cannot, in general, equal one of them divided by the other. That's easy. 4 times 5 is equal to 5 divided by 4. What? So, no. What's the legal way to do it then?
1 divided by 1 over x minus 8.
Yeah, it'd be ln of x minus 8 over the reciprocal. Because how do I divide fractions? I multiply by the reciprocal, right? So this divided by this is this times this, which is what it was. Now, that looks so much worse. But why is it actually so much better? Because now we can apply L'Hopital's rule, and L'Hopital's rule is relatively nice. It's a ratio, but it's not a quotient rule because it just cares about each guy's individual derivative, yes? So I did make the expression worse, but I had to put it in the form so L'Hopital's will work, and L'Hopital's is nice. And now you just take the derivative of the top and bottom and then take the limit. Okay. And you can always write x minus 8 to the negative 1 down there if you want to. That makes the derivative a little easier to look at. Okay, maybe. So you guys, summer is, I don't know if you noticed this, it's condensed, it's very fast. So we haven't had a lot of time to what I call marinate in ideas. And it's unfortunate because I understand a lot of you guys are looking for the quick recipe approach, when with a lot of these problems you actually have to step out of that and just go, okay, what makes sense? What am I allowed to do? What's legal? What can I do? What do I want to have happen? How do I make that happen? Instead of, have I seen a problem like this before? What did he do? He did this for some reason. No. Okay. What else we got?
Is 8b also just L'Hopital's?
Yeah, what's up with 8b? Is it indeterminate, first off?
1, 0.
Bottom 0. Top is 0, yes. Cotangent is cosine over sine. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so 0, 1, 0. So it's indeterminate, therefore, and it's a ratio.
Just L'Hopital's.
So I gave you part B as a straight L'Hopital's, and then part C is, oh shit, I gotta change it so I can do L'Hopital's. And what's part A? Part A is that kind of problem where, is it indeterminate? It cannot be indeterminate because the top would be frickin' 3. There's no indeterminate form of 3. So that's 3 over 0, that's the form it's in. So the answer is going to be some kind of 3 over 0, some kind of infinity. Now you just change your entire perspective to, is it positive infinity or negative infinity? Yes?
So if we just put it on
You know, I have to say, I really appreciate your continued attempts. Here, what I want to see is 3 over 0. That tells me you investigated to see if it was indeterminate or not. Then you could say, how do we determine its positive infinity? Since this is going from above, and in fact, I'm going to 3. So this on top is always positive, yes? And the output to a square root is always positive. So if you gave me exactly this, you show me, you check to see if it needed L'Hopital's. You realize it's some kind of infinity. You check to see what signs everything has. Positive. That's all I need. Okay. When in doubt, show me a little more than you think you should. That does not mean that somebody, they didn't really do this, but like 7 times 8, and I wrote 8 7 times. They did something equivalent to that. I can't remember what it was. I'm like, all right, smartass. Okay, so there are some, if I say what's the integral of sine x, and you write negative cosine x plus c, tears, because you don't need any work for that shit. You're not supposed to have any work for that. It's supposed to be a direct undoing of the derivative. Yes? Yes? You. Oh! Alright, so I think I did the first three, not the last one. So let's do the last one for sure. That's the one you're talking about, right? Huh? Oh, number 13 from 13? Okay, we can do it, sure. And then I have to do 16 because I didn't even do that on the answer key. So hopefully your page was close to right. It's supposed to be coming from the chapter 6 review. So number 13 has this business. Oh yeah. Does anyone else need to practice final? Okay. Look at number 13 up there. Not exactly your choice of problem, right? Okay, so what does cosine look like? Where does it start? At 0, it starts at 1. And then on both sides of 1, it does this. When does it hit the x-axis? At what value? What cosine of what is 0? Pi over 2. So at pi over 2 and negative pi over 2. So it's this mound from negative pi over 2 to pi over 2. Do you guys see how I just described? Because what happens when I square cosine? What's the highest output for cosine? 1. So it's still here. So when I square cosine, it's going to fundamentally look the same. It's not going to look exactly the same, but for the purposes of drawing a sketch, it's this. It's still 0 here. If I square 0, I get 0. Right? And then if I square 1, I get 1. So it still lives in there. So let me move this apart. So the negative, so also, why am I talking about negative pi over 2? Where am I getting that shit from? Yeah, absolute value of x is this, so it's got to be between negative pi over 2 and pi over 2. Yes? So can everybody draw what I just described if you haven't done this problem yet? It's basically cosine between negative pi over 2 and pi over 2. So I've just done it again. I just did it. So draw that out. So between negative pi over 2, pi over 2, it's a dome. Did we go see the Superman movie? Superman. Sorry.
Oh, my best friend did yesterday. I didn't know why she was at the movie.
It's good. It's one of the better DC movies for sure. Yeah.
Don't get much worse.
Yeah, I was about to say the bar is pretty damn low. All right, so for this, it's going to look like this. What else? What other wall do I have? Y equals 1/4, right? This is 1. 1/4 is about right here, so this is y equals 1/4. So can you guys all see, when I look at that, I think of the, what was it called? Justice League and the Fortress of Doom? Sorry. Do you guys see the region we're talking about then? It's that kind of semicircle part there? Yes? We've shaded in. And then we're going to rotate this, because why not, around x equal to pi over 2. So then I can put my dotted line for my axis and put a little arrow, yes? Drawing the situation is crucial for these problems because you need a visual anchor to determine, like, if you're going to do discs, the inner outer radius. If you're going to do shells, draw your little representative rectangle, blah, blah, blah. What would discs require this to do? Integral d what?
dy.
Yeah. Discs would need integral dy. Do we want to do discs then? Because our function is in terms of x, and I do not want to solve for x. I don't want to square root and then take an inverse cosine and work with that shit. What's the derivative of inverse cosine? Okay, what's the integral of inverse cosine? Screw you, Jeff. Yes? So, let me say something now that I just said that. Can you take the derivative of a product by taking the derivative of each piece at the same time? Is that how products work? You guys with me? If I had 5x times e to the x, how would I take the derivative? Would the derivative be 5e to the x and I'm done? I did 5x and e to the x. What do you want from me? What do I have to do? Product rule. I have to do product rule. Well, they each get a term, correct? You with me? You with me? So a derivative of a product is not straightforward. I have to kind of do one at a time. So the integral of a product, for damn sure, doesn't just integrate each piece. Because an integral is trying to undo derivatives, and derivatives don't even work that way. Do you understand what I'm saying? So, I gotta figure out a better way. It's not that integrals are always harder. It's that integrals always have a weird time because they have to work backwards. So whatever rule exists for derivatives, integral has to have an answer. So what's u sub is the answer to chain. It's its best attempt at like figuring out what the shit, where do we start? Okay, sorry. Does everybody understand? Why would discs need this?
Because it's going around a y.
Yes, that's why I always start with discs. Whatever the axis is, if it's parallel to the y-axis, discs needs dy. Do you see why I don't want to do that? Can you solve this function for x easily? Or do you want to solve this function? I don't want to. So what method am I going to use then? Shells, obviously. I don't want to do discs because discs needs this, and my function is a function of x, and it's a funky function of x. So I would rather not solve. Thank you. Do you guys see that? Because a really good problem to have right now is I understand how to do this in shells. I just don't know when to do which. That's why I try to tell you guys, rule out discs. Because it's the easy one. Believe it or not. Is it going to be integral dx or integral dy? Discs, is it parallel to the y? It's y. If it's parallel to the x, it's x, right? And then shells would just be the opposite. And then if your function, if you can't solve for one or the other, then you know which method to use. If you can, then it becomes a question of which way would lead to an easier integral. Then you get to choose. Okay. So everybody see that? This one I definitely want to use shells. What do I need to draw in to get shells started?
Your rectangle.
Representative. So the whole idea of shells is it's kind of like when we did, I don't even know if I used the phrase Riemann sum, but that's what we did when we drew the rectangles. And we did like 6 rectangles, one of those are called Riemann sums. I didn't give him props, so he rolled over his grave, but he'll be. So if I draw the representative rectangle, that's what we're actually going to rotate to make that shell, that cylindrical shell, yes? So if I draw that in for myself, it helps me do everything. It helps me figure out the radiuses, and it helps me figure out what the height is. So people that don't draw that in do not make sense to me. So if it's discs, I want to figure out the radius or the radii if it doesn't hug the axis. For shells, I want to draw in anywhere a little representative rectangle. Where is that? Don't overthink it. Where is it? X. Beautiful. So what's the rate? Where's my axis? Here. So big minus small. So what's my radius? Pi over 2 minus x. If x was pi over 2, what's pi over 2 minus x? If x is pi over 2, what's pi over 2 minus x? 0. So the radius would be 0 if it was here, correct? What if x is negative 1? What's pi over 2 minus negative 1? Pi over 2 plus 1. That's why it gets a little longer, doesn't it? So whatever you think the radius is, you can actually give yourself some concrete examples and go, okay, that makes sense. So how did I just determine? How do I always freaking determine the radius? I start at this and I go to where my rectangle is. I take big minus small, bam, that's my radius. What else do I need for shells? The height. What's the height of that rectangle? What's the top? Don't think of a number, think of what it's hitting. What's the top? Cosine squared x. And what's the bottom? So how tall is it? Cosine squared x minus 1/4. That's how tall it is, yes? Do you see how both the ideas are the same? Big minus small, big minus small. Because both the radius in this case and the height are just how far did I go here? How far did I go here? That's why the math is the same in both cases, because it's representing the same idea. So my height will be cosine squared x minus 1/4. Oh, and by the way, did you read the problem fully on this one? What did the problem want you to do in number 13? 13, Jeff. Don't sharp on. Just do this. There it is. Set up, but do not evaluate. Because, dear God, you do not want to evaluate the interval. You can't. Even if you wanted to, you can't. You guys with me? So this one is just setup, and a lot of the times the setup is the worst. This time, the integral is actually impossible for us to do. Okay, so let's do this immediately. I've got 13 on the answer. I don't have 16. I haven't even looked at 16, so I forget. Was it 16? Yes. Let's do 16 right now, and then we'll go back to whatever you guys want to do. So read through 16 here. This one wants me to actually do it. And it's telling me to do it 2 different ways. Oh shit. Oh yeah, that's right. Let's do this. Using X and using Y. I like it. You would like it, Jeff. One thing you guys, some of you guys skipped on the problem, I think it was the first one of the top ones that used disks. You didn't show me how you figured out where the two functions met. Even if I don't say do it algebraically, I want to see it. So I just gave away the answer to this, what I'm about to ask. In order to sketch the region, what do I need to do first? How do you determine where the region is? I want the region that is captured by those two functions, yes?
You would find where they intersect.
I have to find where they intersect, because then in the middle is where they capture, yes? So if I had a function that looked like, come here, there. If I had a function that looked like this, ha, and I had a function that looked like this, ha, where's the region that they capture?
Between where they intersect.
Yeah, this region right here, yes. So therefore, I have to know where they intersect to know what defines that region. What x value or y value, what x value, does it go from to? So algebraically, what do I have to do in number 16?
You want to set them equal.
Set them equal to each other. All right, go for it. I'll wait. Get away from me. Not that far. Oh, man. Poor little guy.
Yeah. Oh,
So you take the square root of x, you set it equal to x squared. And then you solve it. Yeah, that's square root. Okay. What's x squared next to that? Yeah. Equals. There you go. Now, do you have a variable with a higher power than 1? Or a different power than 1? Yes, so get it equal to 0 and then factor. Always. When you have a variable in your equation that's different, and a variable has a power different than 1, it equal to 0, factors. So subtract to make it yellow. So you guys might realize why I assigned this one, because it's got my favorite form of factoring involved. Or you just say equal to 0 and solve. You don't have to factor, to be honest. Somebody with me? What do you get when you set those equal to each other? So you get square root of x equals x squared, yes? Now you keep going. What sucks about that? What can't we handle in this? The whole thing, Jeff. Screw you, Jeff. What can't I handle here? Square root, kill it. Now don't divide by x, because x could be 0, so you can't divide by it. You just can't divide by 0. So what do I do instead? Like I was just telling Nat, if I have an equation with a variable with a power other than 1, I almost always want to get it equal to 0, because then I can factor. Now, a quick little thing about x cubed minus 1, which is something you would have gotten in pre-calc, but again, I'm not sure how foundational it really was for everybody. If I have a difference or sum of cubes, it will always have one real answer and two imaginary. Always. And it's unfortunate if you don't really know why. Makes me a little sad. So I'm not even sure I can explain it. You guys remember I was talking about complex numbers and how like square root of -1 is just rotating by 90 degrees? You guys remember that? If I multiply by -1, it's a 180 degree rotation. 1 times -1 is -1, correct? Didn't I just rotate by 180 degrees? So 1 times the square root of -1 is half of a rotation, so it's here. I'll stop, I'm sorry. That's really unfortunate. So, if you just remember this, it's going to start sinking. If I have a little cubic, a sum or difference of cubes, it can only have one real answer. The other two answers it must have because of the fundamental theorem of algebra, which says if it has a third power on it, it's got to have three answers. The other two will always be complex. And is this class calculus of imaginary numbers? No. Sorry if you wanted it to be. I wasn't allowed to do that. So what are my two answers then? X is 0 or x cubed equals 1, yes? When's x cubed equal 1? Okay, good. Now, that was all of that was just to get the very first part of this done. So now I know they meet at 0 and they meet at 1. So here's what you can do. The two functions were square root of x and x squared, yes? So they meet at 0 and they meet at 1. So this is kind of dumb because we know what these look like. At 0, they're both 0, correct? At 1, they're both 1. So now it's just a question of connecting those correctly. Neither one of them is a straight line. Which one bows down? Which one is concave up? Oh shit. Which one bows down? X squared does. And of course, what's the square root look like? Yes, it goes that way. So when I connect these, this will be x squared, and this will be square root of x. That's all you ever need to worry. Now that one was a little bit easier because it was all determined by who's curving which way. If you know where two things meet, get those points, plot them. Pick any number in the middle and see which one's bigger than the other one, and they will forever be that way. Because the only way one function can change places with the other one is if they in the middle meet. And if you found where they meet, they can't change in the middle. I don't know if that makes any sense. So if I would have just plugged in 1/2, I could see which one was on top and which was on the bottom, because that's really the only thing that matters. Now I have currently forgotten what we're doing. Where are we rotating this? I forget. Was this 16? Yeah, we're rotating this around what? Let's see. We're rotating this around y equals 3. Of course, why not? So the great thing about the sketches you make for these problems is it doesn't have to be to scale. It's just supposed to be a visual anchor to work with. So it doesn't have to be pretty, it doesn't have to be perfect. Just make these line no harder. So if I wanted to use discs, what would they require? In fact, this one, that's right, this one they want us to do it both ways. If I wanted to use discs, what would that require? Interval D is what I'm rotating around parallel to the y-axis or the x-axis? Yeah, the axis I am rotating around is parallel to the x-axis, so discs would need interval dx. So then, now I can focus all my attention on discs, because part of what they asked me to do is everything in terms of x. So when I do everything in terms of y, I'm obviously going to have to use shells. So this is a really good problem. This is one reason why I assigned this problem. It's because you do the same problem 2 different ways. So if you get the answer, you better get the same answer the other way, because there's nothing changed about it, yes? So is everybody cool with the fact that part of this wants me to use x's? If I use x's, that's discs. Is that cool? How did I know that? Yeah. No. Whatever my axis is, if it's parallel to the x, discs needs dx. If it's parallel to the y, discs needs dy. Period. And whatever discs is, shells is the opposite.
Oh, okay.
Because I find my disc on the x-axis. But I find my, like when I do, I gotta do it parallel to this, so I find my represented a rectangle on the y-axis. That's why whatever one is, the other one is the opposite, because they kind of use perpendicular ways to find stuff. Okay. Sorry, some of your faces. Faces you make, not your face, not your resting face. So let's see. Now that we've chosen discs, just because it wants me to do both ways, so I just might as well start with discs. What do I look for? Is this going to be a situation where I need an inner and outer radius? And how do you know?
It doesn't hug the axis.
Yeah, the axis is really far away from us. Not only is it not hugging, it's like I'm like, what is here? So how do I draw in my inner radius? That sounds like a yoga class. Find your inner radius, everybody.
We start at the axis.
That's
line,
crazy.
and draw it down, and whatever hits first
Yep.
is our inner.
Beautiful. So if I start at the center, and I go until I hit, so what's my inner radius?
Y equals 3x.
Huh?
Yeah, that one's the first one, right?
Sorry? Y equals square root of x.
Oh, yeah.
Okay. So then what's my outer radius going to be? Incredibly enough, it's going to be the only other function in the whole thing.
This is x squared.
X squared. So then how does this get set up? What's it look like?
We do outer minus inner.
Our outer
Squared.
squared. Because it's based on pi r squared, right?
Do you have to worry about the fact that the x is 3 at all with the?
Oh, I'm being silly. Oh my god. I'm not even really doing what I'm supposed to be doing. So, our inner goes from here to there. How long is this? How long is this? Well,
3x plus 3 or minus 3?
how long is from 3 to 2? How long is that?
1,
How long from 3 to 1?
2.
What do you keep doing?
You're subtracting.
Where I start minus where I end. So where do I start at 3 and where do I end?
Would be 3 minus 3.
Yes, there we go. That's my fault. That's all I didn't even think about it, that our axis is off. So what's the outer radius going to be? Same idea, really.
3 minus x.
Yeah, 3 minus x squared. Good. So that's what I'm going to have to plug in here. What are my limits going to be? What variable am I looking at to determine my limits? And it doesn't matter for this one because they both go 0 to 1, but yes. Do it again. Then you're going to get a negative answer, which is really weird for volume. It's like some really weird material. So this is why if you draw everything in, to figure out how long something is, it's where the bigger part minus the smaller part. So this 3 is bigger. This wall is smaller, so it's 3 minus this wall, 3 minus rad x. Same thing for the outer radius, it'll be 3 minus x squared. What's the limits for the interval? Somebody's mouthing it to me. 0 to 1. Why 0 to 1? Why are the limits 0 to 1? What is x doing? In our region, what is x doing? Going from 0 to 1. Hey, that's it. Yeah. So whatever this is, that's one of the first things I have you guys do is the integral dx or integral dy, because that sets up basically how everything else kind of works. Now I'm just going to put 3 minus x squared. I'm going to put that in for our outer. And then I'm going to put 3 minus rad x in for our inner. And in the grand scheme of things, this is actually really nice. Yes? I know it's got a radical in it, but who cares? It's x to a power. As far as integration is concerned, that's easy. So I would FOIL, combine like terms, and then integrate. Some of you guys are doing the classic, you don't integrate. And I think it's because part of your brain is like, I did a lot of work, I must be almost done. But here, I've got to simplify the inside, and then I got to integrate. Okay, so don't forget to integrate. Are you guys with me? So what do you get when you FOIL this bad boy out? We get 9 minus 6x squared plus x to the 4th, yes? And then over here, you're gonna get 9 minus 6 rad x plus, what's rad x times rad x? X. Sounds like I'm talking about Dragon Ball, but sorry. Can you combine any terms? The 9s die. That's always nice to see. Like, too many terms. Oh, 2 of them kill each other. Oh. So we get negative 6x squared plus x to the 4th minus negative, so plus 6 rad x minus x. And this is why I say setting it up is hard. That needs to be easy. I could rewrite rad x as x to the 1/2, right? That would make it a little bit easier. Some of you guys are still putting the power in the wrong place when you rewrite radicals. What's on the bottom? When you have like a root of something, the 3rd root of x to the 4th. what would go on the bottom and the power? Because the roots are on the bottom. That's how you keep it straight, yes? If you rewrite radical wrong, then that's gonna lead to no chance you can get it right. Now, I would give you partial credit, obviously, if that's the only mistake you made. Is that okay? Well, might as well, let's see, how's this thing keep going? What do you, when you iterate this? This is nice. Why is that nice? What does 6 have in it that's nice? It's got a 3 in it, and that 3 can just go right back up. This one's not as nice, but still, x to the 5th, so in front I put a 1/5. This, I'm gonna rewrite as x to the 1/2. Now how does that work? Here's how I do it, you ready? Plus 6, x to the 1, what's the 1/2 become? 3/2, and then in front I'm gonna put 2/3. And then I worry about this next, yes? Some of you guys did some really magical shit on the test that just suddenly the answer came out. I'm like, where the hell did that come from? So show me where things are coming from. And then minus one and a half, yeah, okay, 1.5 x squared or x squared over 2, that's fine. 0. And there's a little, you know, if you have a parenthesis, you can just put the limits on the parentheses so you're not throwing too many things. Now you plug a 1 in. The great thing is, in this case, if you plug a 0 in, everything's 0. Be really careful, don't just assume that, because each of the zeros is 1. So whatever the hell you get when you put 1 in, what is that? Stuff, 2, what's that? -3/10. 1 and 7/10, 1.7, I think. 1.7 pi. Maybe? Yes? Yay. Go, Jeff, go. Is that okay? So again, what's important for you to notice is how do you tell if it's shells or discs? Right? In this specific problem, we can go back and do shells to it, but before I do that, I want to make sure, anybody else have anything specific you want to talk about right now? I want to redo this problem. What did I get? 1.7 pi? I think that's right.
1.7. Yeah, 1.7.
Pi. Okay. If we do it with shells, we must get that same answer because it's the same volume. Okay. You doing okay? What's up? Do what? Of course, yeah. I love you guys so much. Is that really, are you guys like, I can't say anything to this guy? Okay, of course. Let's take a break. Yeah, yeah, it's summer calc. Summer calcing gets really crazy. All right, guys, let's see. I don't know, how long of a break do you want? Huh? 7 weeks, Jeff. No, Jeff. Nobody tried that. Normal amount? So 5, 10, what did I give you, 20 minutes or 15? 20? So 10 after? Come back at 10 after. Really? No, you did everything fine. I think.
I didn't know how to get that, so I plugged in a big
I see. You would just do a quadratic form.
Oh.
Yeah. But to be honest, I didn't take points off for that because this is the only problem the only version that ended up with somebody who did it faster. So as long as people got there and did something after I was giving everything, but yeah, you would just do quadratic form. Yeah. Sure.